Hi everyone, today we're doing the section 3.4 notes on chain rule. This is a really important rule and it's a part of practically every derivative problem that we're going to do, and we actually have done, you just didn't know it. So the chain rule says if you have a function that is a composite, okay, and all functions can be considered composites, and I'll show you how, then the derivative of that composite is going to equal the derivative of the outside function times the derivative of its argument. The argument is the inside. Okay, so this is times the derivative of the argument. And this is just another way of stating it. If you have a function f of u, then its derivative is the derivative of the function f prime of u times du means derivative of u, which is the argument. So I'm going to demonstrate this with several examples. So find the derivative for each and every one of these problems. So if we begin with h of x is equal to 3x plus 2 to the fourth power, what would you do if this problem was not 3x plus 2 to the fourth power, but it was, for example, and I'll do it in this bubble here on the side, h of u is equal to u to the fourth? Well, you would say that the derivative of h of u, you would do the power rule, bring 4 to the front, reduce the power to a 3, and say that's my derivative, and you would be correct. Except now, in chain rule, we have a times du, which means the derivative of u. And if you look, in our problem, the derivative of u is 1 in this problem. So we really haven't noticed up to now that we've been doing chain rule because it's been times a 1. But now, if you think of this as your u, then the derivative of h, okay, so you would put 4 times 1 in front. Power rule is what's happening now. 4 times 1 in front. Copy the u, right, the inside function. Decrease the power to a 3. So I just finished doing the power rule so far. But then according to chain rule, I have to do times the derivative of the inside. Well, what's the derivative of 3x plus 2? It is 3. My final answer to this problem is 4 times 3, which is 12. 3x plus 2 to the third. Okay, let's do several more. What if I have h of x is equal to the square root of negative 8x to the fourth plus 9x plus 2. So first of all, I want everybody to write the rad as a numerical exponent to the half. And so we are ready to do the find the derivative of h, which we begin with the power rule. There's a 1 in front of, this is called the argument, okay? This is that little g of x. So we're first going to find the derivative of f, this set of parentheses being raised to the half power. So we're going to do the power rule first. 1/2 times 1 is 1/2. We're going to copy the argument. We're going to minus 1 to this degree. What's 1/2 minus 1? Okay, we just finished the power rule portion of it. We finished this part. Now we're going to do times the derivative of the inside argument. So times, what's the derivative of the inside argument? What's the derivative of negative 8x to the fourth plus 9x plus 2? It is negative 32. 4 times negative 8. X to the, you're going to decrease the degree by 1. Plus, what's the derivative of 9x? It is 9. Plus the derivative of 2, which is 0. So I'm not going to do anything there. My final answer is this. I don't want any negative exponents. So I'm going to have a fraction here with a 1/2. I'm going to have the negative 32x to the third plus 9 on top. You really don't have to have this 1, or you can. And then I'm going to have either to the half power or a square root, negative 8x to the fourth plus 9x plus 2 to the half power, or under a rad. in the denominator of this problem, and that's the answer. Okay. What if I have f of x is equal to sine 3x? So hopefully by now you have learned that the derivative of sine is cosine. So if the problem had said f of u is equal to sine u, okay, if, this is if, then the derivative would have been just cosine u. But now, with chain rule, the u becomes the argument, so you have to do times the derivative of u. And so what's the derivative of u? In this bubble here, it is 1. But here, our u is 3x. So we won't have a times 1 at the end, we'll have a times 3. So the derivative of sine 3x, first of all, you have to remember your trig derivatives, is cosine 3x. So we did the trig part, but then we have times the derivative of the argument. What's the derivative of 3x? It is 3. The final answer to this problem is 3 cosine 3x. Okay, let me do several more because I think chain rule really requires a lot of examples. Okay, number 4. I know f of x is equal to 1 over the cube root of x to the third plus 5x minus 7. You want to for sure write this in its exponential form instead of a rad. So you know that cube root means to the 1/3 power. I'm also gonna strategically write this in the numerator with a negative. I don't want a quotient. This is a quotient the way it is. It's not gonna be impossible, but it's gonna be a more difficult problem to do. So I'd rather not have a quotient if I can avoid it. So I'll have x cubed plus 5x minus 7 raised to the, I know this is 1/3, but it's in the denominator, so negative 1/3. All right, I'm ready to begin my derivative. So there's a 1 out here. We want to do the power rule first. We want to pretend this is like a u. How would I do the derivative of u to the negative 1/3? I would do the power rule. Negative 1/3 times 1 is negative 1/3. I would write u, correct? And I would raise it to 1 less power. What's negative 1/3 minus 1? It's negative 4/3. And now we have chain rule kicking in, which means not only do you do the derivative of the function, you do times the derivative of the inside argument. So I have to do times the derivative of this. What's the derivative of x cubed? It's 3x squared plus 5, the derivative of 5x is 5, minus the derivative of 7, which is 0. And I'm done. So as a final answer, no negative exponents, I will have a negative 1. I have a 3x squared plus 5 in the numerator. And in the denominator, I have a 3. And then I have this x cubed plus 5x minus 7 raised to the 4/3 power. And I just leave it like that. I'm done. Next problem. What if I have y equals 3x over 2x minus 1 to the 5th? Okay, so what's the derivative? Pretend this says u. All of this is u to the 5th. How would you find u to the 5th power? Well, you would put 5 times 1, exponent times coefficient. You'd write u, so I'm going to write 3x over 2x minus 1, and you'd drop the degree to a 4. That would be if it had said 1u to the 5th. You would get 5u to the 4th. But now, with chain rule, we have to do times the derivative of the inside. The inside happens to be a quotient. So when you do the derivative of the inside argument, you're going to require it's going to require the quotient rule. So this is what we have. 3x over 2x minus 1 to the 4th. All right, here we go. We're going to do the quotient rule on this, which says derivative of top times bottom minus derivative of bottom times top over bottom squared. Okay, we're going to clean this up a little. Watch. We've got a fraction here. We've got 5 as on top. We've got 3x to the fourth. We've got 6x minus 6x, which is nothing. Then we've got minus 3 over 2x minus 1 to the fourth and a 2x minus 1 squared. So here's how I'm going to write my final answer. This is easy enough for me to do. 3 to the fourth power is 81. What's 5 times 81? 5 times 81, I believe, is 405. X to the fourth minus 3 all over. And I'm just going to write this as 2x minus 1 to the sixth power. That's my answer. Okay. Let's do a couple more. Number 6, how about y equals tangent 5x? So first things first, think, what's the derivative of tangent? Is it not secant squared? So if this said tangent u, you would write secant squared u. But it doesn't say tangent u, it says tangent 5x. So the derivative is secant squared 5x. Chain rule kicks in. Times the derivative of the argument. That's the argument. What's the derivative of 5x? It is 5. My final answer is 5 secant squared 5x. Let's do another one. I think I want to do about 6 more here. How about y equals sine 3x times cosine 4x? You guys, this problem is a product. This is F, this is G. Let me remind you of the product rule. F prime G plus G prime F. Now, if I'm going to do F prime G plus G prime F, then I'm going to do the derivative of sine 3x. What's the derivative of sine 3x? The derivative of sine is cosine, but I have to do times the derivative of 3x, which is 3. I'll just put it in front. This whole thing is F prime, times G, which is cosine 4x, plus, so this was G. Now I have to do G prime, so I have to think, what's the derivative of cosine? The derivative of cosine is negative sine 4x. But I have to do times the derivative of the argument. The derivative of 4x is 4, so I'll just put it right here. This completes the G prime times F is sine 3x. And then I clean this up a little bit and I get as my final answer 3 cosine 3x cosine 4x. Those cannot be combined. Minus 4 sine 4x sine 3x. It's done right here. That's the answer. Okay. Number 8. Hang in there, we're almost done. So y equals x to the fourth, x cubed minus 2 to the fifth. Okay, we have on our hands another product, f and g. So the derivative says f prime g plus g prime f. This is the product rule. What is the derivative of x to the fourth? It is 4x cubed times g the way it is, x cubed minus 2 to the fifth. So this is f, this is g. Okay. Plus it says the derivative of g, the derivative of this. Now there's a little 1 in front of the parentheses. So power rule first. 5 times 1 is 5. Copy the inside. Finish your power rule by minusing 1 to the exponent times the derivative of the inside. This is chain rule kicking in. What's the derivative of x cubed minus 2? It is 3x squared. That finishes, this whole thing was g prime. Times f, which is x to the fourth power. clean it up and move on. So 4x to the third, parentheses, x to the third minus 2 to the fifth. Over here I've got 15 x to the second times x to the fourth is x to the sixth, parentheses, x cubed minus 2 to the fourth. Done. You can just leave it here. It is factorable, but we're not going to worry about it. Number 9. How about y equals, oh, this is a good one, cosine squared 5x. So first things first, I want everyone to recognize that this problem is actually this problem. Okay? And when you realize that this problem is actually this problem, and you realize there's a 1 in front, you see that in order to do the derivative, you have to do the power rule first. So 2 times 1, copy everything in the middle. This is the argument here, argument, minus 1 to the degree. Then chain rule kicks in and says times the derivative of the argument. So now you have to say, what's the derivative of cosine 5x? The derivative of cosine is negative sine 5x, but then it had its own little argument of 5x, so times 5. Final answer, 10. 2 times 5 is 10. Oh, we have a negative, 10 actually, because of that negative. Cosine 5x, sine 5x, and it is done right here. Number 10. How do you do y equals sine of sine x? Where the argument of sine is sine x. Well, first of all, if this said u, if the problem were y equals sine u, wouldn't you say that the derivative is cosine u? But u in our instance is sine x. Chain rule says after you do the derivative of the outside function, you do times the derivative of the inside. So what's the derivative of sine x? It is cosine x. And that's your answer. Cosine of sine x times cosine x. Done. Well, I don't know why I recopied it. I didn't do anything different, but that's the answer. Let's do 3 more. So number 11. Y equals e to the 2x power. I think everyone knows that the derivative of e is itself. So if it said y equals e to the u, wouldn't the derivative be e to the u? But chain rule says times the derivative of the argument. And in a function like this, the argument is the exponent. Okay? And so the derivative is going to be e to the 2x. The derivative of e to the 2x is itself times the derivative of its argument. The derivative of 2x is 2. So the answer is 2e to the 2x. Let's do one more. Y equals e raised to the cosine 8x power. So the derivative is itself, okay, the derivative of e is itself, times the derivative of its argument. What is the argument? It is cosine 8x. What's the derivative of cosine 8x? The derivative of cosine is negative sine 8x. But if this were a separate problem and I had said do cosine 8x and find its derivative, you would do times the derivative of its argument, which is 8x, and so you'd have a times 8 in the end. Okay, final answer should look like this. You should write negative 8 first, and then you can write e or sine first. It really just doesn't matter which one goes first. They are both lovely. There it is. This is the answer. Okay? All right, there's one thing left on these notes that I have to tell you, and that's how to find the derivative of an exponential function like e. So derivative of exponential functions, all, not just e. And so we know that if y is equal to e to the x, then y prime is itself. But actually you're following a formula. So here's the formula you're following to get this. If y equals a to the x, any number to the x power, 5 to the x power, 4 to the x power, then the derivative is itself, okay, times ln of the base, all right, times the derivative of the argument or the exponent. So you'll notice in e, if you follow the formula, you copy the function e to the x, then you go times ln of the base, ln e, which is just 1, times the derivative of x, which is also just 1. So it ends up being e to the x. So let's do 1 or 2 examples. If y equals 7 to the x power, then the derivative is, follow the formula, itself times ln of the base, this is the base, times the derivative of the exponent. What's the derivative of 1x? It is 1. So it's just 7x times ln 7. Let's do just one more. What if I have y equals a raised to 3x squared? So the derivative would be the function itself times ln of the base times the derivative of the exponent, which is, what's the derivative of 3x squared? It is 6x, and you simply just leave these the way they are. You don't have to worry about simplifying them. That's the end of the notes. Thank you so much for watching. See you in class. Bye.